If you have 27.45 moles of barium hydroxide, what is the mass? Anytime we are trying to convert between mass and moles, whether we're going from mass to moles or going from moles to mass, you still have to calculate a molar mass. Okay, and a molar mass, by definition, is the sum of all the atomic masses of all the atoms in a formula written in units of grams. And then in this class, not only do you have to put the unit of grams on there, you have to put the species next to that and say that's equal to 1 mole of that same species. We have barium hydroxide. We need to know what this is and what that is. Okay, now you've got two sources for looking those things up. One is a periodic table and one is a common ions list. So if we look on the periodic table, you'll eventually find, if you're persistent long enough, that you got barium right here. That's Ba. Okay, Ba. And then hydroxide is not on the periodic table. Yeah, so if you don't find it there, you need to go to your common ions list and see if you can find a polyatomic ion there. Okay? And if you go through this far long enough and are persistent enough, you'll see that hydroxide is OH negative. All right. To build a formula from this, we need to know what the charge on the barium is. We know what the charge on the hydroxide is because it was on the common ions list. But to find the charge on the barium, you need to go, since that's an element, you need to go to the periodic table of oxidation numbers. Okay? And barium is right down here, and it shows it with a 2+ charge. So barium has a 2+ charge, and hydroxide has a 1 negative charge. We need the overall formula we build to have a neutral charge, 0. So if I have a 2+ on the barium and a 1 negative on the hydroxide, I need to know how many of each of these I need to get to a 0 overall. And CJ, I assume you mean a 2 here, okay, and a 1 here. Well, and that's correct. So that means there are 2 hydroxides in a balanced formula. When we write the formula, listen please, when you write the formula and you bond 2 hydroxides which contain 2 different elements, you've got to use subscripts to show you have 2 hydroxides. When it's bonded together, you use subscripts to show 2 hydroxides. So we're going to put hydroxide here and a 2 afterwards, but to show 2 hydroxides as opposed to 2 hydrogens, we have to put a parentheses around the hydroxide. So now this 2 applies to both hydroxides, and it means you have 2 oxygens and 2 hydrogens. Okay? So now, going back to the definition of molar mass, we need the sum of all the atomic masses of all the atoms in the formula. So we go back to the periodic table, and we see barium's atomic mass is 137.327. So barium is 137.327. Okay, oxygen on the periodic table is 15.9994. And I've got 2 of them, so I have to have the sum of all the atoms. The sum of the atomic masses of all the atoms in the formula, 15.9994. And I've got 2 hydrogens. Okay, hydrogen is 1.00794. And since I've got 2 of them, I've got to put it twice. Okay. Now we're ready to add all those up. Now referring back to the rules about adding and subtracting, And significant digits, remember, anytime we have numbers added to some empty slot to the right, then we have to round those numbers off. So I've got an empty slot above this 4, here and here, and I've got 2 empty slots above this 4. So when I finish adding it all up, I've got 2 numbers I've got to round off. Okay? Let me slide it up here a bit to give us some room to see what's going on. You need to get out your calculator and practice what to so that you can get good at this. All right? 137.327 plus 15.9994 plus 15.9994 plus 1.00794 plus 1.00794. Okay, and I got 171.34168. Alright, so I've got 2 digits here added to some empty slot in the column. So they get rounded off. I use an arrow to show rounding. This number is not going to be equal to the rounded number. You can't use an equal sign. You have to use an arrow. 171.34. This 6 makes this round up to a 2. 3, 4, 2. Somebody at my door, or is that another? That's the door next door, okay. And that is, by definition, this is the molar mass. The sum of all the atomic masses of all the atoms in a formula. Okay? And written in units of grams. In this class, you also have to write that this what this grams applies to. It applies to barium hydroxide. And also in this class, you have to say that this mass of this species is equal to 1 mole of this species.
So how did you get the 171.342?
I added all those numbers.
No, I'm saying like you only underlined 8.
Alright. Because I've got empty slots in this column and an empty slot in this column. Because those 2 numbers are the result of adding empty slots.
And all the numbers in that thing that go through here underlined.
Basically, if... Okay. Alright. Alright. So now we have an equality statement. And it's an equality statement because we've got an equal sign here between 2 values. Anytime you put an equality statement into a fraction such that one side is over the other, this side can be over that too. The fraction that you're building is equal to 1. This is going to allow us to convert an amount without changing that amount. We're only changing how it's being measured. Okay? So we're going to put our starting amount over 1. 27.45 moles of barium hydroxide over 1. And then we're going to use this equality statement to build a conversion unit. What we want to do is to put in this equality statement, in this conversion unit, the side of this equality statement that matches the beginning units and species, or the units and species that are still left in the problem.
1 mole of barium.
Right, 1 mole of barium hydroxide is the side that matches the units and species, so it's going to go on the bottom of the fraction. And this other side then goes on the top. Alright, now we're going to do the dimensional analysis part of this, where we cancel units that are the same on the top and bottom, and species that are the same on the top and the bottom of these fractions, just like you cancel x's and y's in algebra. And by doing so, we canceled all of these units and species and left us with the units and the species that match what the problem is asking for. The problem is asking for mass, and this is a mass measurement. And it says, what is the mass of barium hydroxide? And that's what we're finding the mass of. Okay? This is called dimensional analysis because it cancels all the units and species except the one we're looking for. Okay? So now you're ready to put this math in your calculator. This number times this number. Since these numbers are on the top, we don't have to divide by 1. That's the same answer. All right? Anytime you divide by 1, you get the same answer you started with. Right? So all we have to do is multiply those two numbers. Has anybody done that already?
Yeah.
Okay? Well, if you haven't, get out your calculator and do it. You need the practice. You need the practice. So that's the number I got on my calculator. Your calculator may give you a couple fewer digits. That's okay. Or maybe it gives you exactly the same number. All right. Now we're going to look up here, and we're going to look at the measured numbers and the calculated numbers, and choose the number that has the least digits, and then round off our answer to have that same number of digits. So this number has 6 digits. This number has 4. 4 is less than 6. So I want my final answer to have this lowest number of digits. We don't worry about the ones down here because those are counting numbers. They haven't been calculated. They've been just put in there for a placekeeper, basically.
Why do you want that to be lowest amount of digits?
What now?
Why do you want that to be lowest amount of digits?
I can't hear you. Oh, lowest, because that's the way that you keep your answer from having more digits than are justified by the calculation. Okay? Any digit after the 4th one is it's an unrealistic digit. It's an unsubstantiated digit. Okay? It's called an insignificant digit. What?
My calculator automatically gave me, when I said 4,703.64.
Well, okay, so we're going to, this is our first significant digit. 1, 2, 3, 4. We have units of measurement of grams, and we have a species left, we haven't canceled out here, of barium hydroxide. And so now we're ready to write our rounded off answer. About what? No, we don't need to because we're not rounding off a number in the ones place. The question is, don't we write this answer in scientific notation? We would have to if the number in the ones place is being rounded off. But since it's not, we don't need scientific notation. About what?
I told you that it rounded it automatically.
Yeah, I've kind of been trying to ignore him, but... Okay. Alright, look. If you want me to help you fix your calculator, come see me outside of class. I'll be glad to do that, okay?